Right. So people, and another thing, since I'm recording this on my computer, if my laptop got off, the latter part of my recording will not be there in the recording. So please excuse me for that. Right. So I will upload the part up to the recordings. Right. So this is the place which we start last week. We talked about the expressions, and yeah, I think some of you have here to some of my students from the 2022. Bashita, පුතා අපි operating system next half එකේ පටන් ගන්නෙ මේකේ gates ටිකක් යන්නේ කියන්නේ 12 මාර විතර වෙනකොට 12 මාර 12:40 විතර වගේ වෙනකොට operating system පටන් ගන්නවා. එතකොට connect වුණත් කමක් නැහැ භාෂිත. right? ඔයාලට මේ ටික අවශ්‍ය නම් හිටියට කමකුත් නැහැ. no problem. right? Right. So we discuss about the two expressions which we call the sum of product and product of sums, right? And we get to know there are like standard types, non-standard types, and we know how to standardize a non-standard SOP as well as standardize in a non-standard POS, right? And later we talk about how to convert a POS into SOP and the SOP into POS, right? So we are through with these things, and I'm not going to push you hard on these conversions because it is very minimal. Minimal means still we haven't get any questions regarding this SOP POS conversions in the examination, right? We are giving the questions to the term tests and all these things, but not in the major exam like the A levels. So I'm moving to the next section. Now the next section is an important one, right? Where we are going to discuss how to derive a particular POS and SOP once we are provided with a particular truth table, right? So truth table is given, right? Or like later you will learn how to derive a truth table according to the scenario, right? So then after we are going to talk about how to derive a SOP and POS from the given particular truth table. So for the moment we are assuming the truth table is there. Either it is given, or either we have derived it, right? Or we have constructed it, right? Later you will know how to construct the truth table, like once a particular scenario is given, right? So I'm going to move to your note over here, right? Instead of going through the whiteboard, right? Just a second, let me take your note. Yeah, so in your note, in the page number, yeah, this is the place. Yeah, over here in the page number 14, right? You may feel that we know some of these already, but I'm just taking your attention of deriving an SOP using a truth table. So here I have taken a particular truth table. So just concentrate on this, right? So this is a truth table which has 3 inputs, which is A, B, and C, right? So which is given the combinations of ones and zeros in this particular manner, right? And output is indicated by F, and it has some outputs like 1 over here, 0 over here, and 1 over here, and 0, 1, 0, 1, right? So what I'm trying to say is, So the next column, the very last column, is the complemented answer of the F. That means the output. That means F bar, right? So you can derive the SOP for F as well as F bar, right? So first we are concentrating on one particular thing, which is the F, the output, right? So here, what you have to consider is when a particular truth table is given to you, first thing, you should have the output column filled with the corresponding outputs, right? So it will depend on a particular scenario. ඒක ඔයගලන්ට දීලා තියෙන මොකක් හරි සිද්ධියකට අදාළව තමයි complete වෙන්නේ, right? We'll talk about it later. At the latter part of the lesson, we are going to talk about it, right? So for the moment, we are assuming this F column or the output column is filled with ones and zeros. So to write an SOP, this is the important part. To write an SOP, we consider the places where you are having one as your output, or like where you are having one as an output on your output column. Output column එකේ එක place වෙලා තියෙන තැන් තමයි අපි SOP එක ලියන්න consider කරන්නේ. Right? And when you are writing a particular expression, first of all, the places which indicates by 1 in the output column, I'm talking about these places. These are the places which indicates 1 in the output column. It can present you the specific term that belongs to the SOP, right? So what we are doing is we are just deriving the terms. You can see I have written some terms over here. I'll tell you how the terms are being generated, right? So first we generate these terms, then we write the SOP using those terms, right? So what is the basis? Once the truth table is given with the output, we consider the output column and we consider the places which got ones, and to that particular one, we are going to write a particular SOP term. Then considering those terms, we are going to write the total SOP expression. Now you can remember SOP stands for what? Sum of products. So that means there are products which needs to be connected with a plus sign as a sum, right? So as the terms which are belongs to or which are indicated by 1 are written as a product. ගුණිතයක් විදිහට තමයි මෙතන terms ටික අපි ලියාගන්නේ. Right? Then later those terms are connected using a plus. That is how sum of product has been deriving for this particular truth table, right? So we consider about the 1. Now first let's talk about this particular one. Now this particular one has the combination which indicates 0, 0 and 0, right? So when you are deriving a SOP from a truth table, 0 indicates the complemented state of a variable. That is very important. 0 indicates the complemented state of a variable. That means if your variable is A, 0 indicates A bar or A dash. Is that clear, people? Okay. And 1 will indicate 1 will indicate the natural state or the non-complemented state. That means 1 will indicate A. 0 will indicate A bar. When we are going to consider this when we are going to consider it like this, when we are writing a SOP, sum of product, right? So we take the output column, we take the ones, the places where it have ones as the output, then we consider what is the input combination to that corresponding one. So we have 0, 0, 0 over here. So that means these 3 zeros are indicating A bar, B bar, and C bar, right? So here we go. We write the term as A bar dot B bar dot C bar, right? It is because output has 1. So we are going to consider this one as a term of the SOP, and that 1 has the input combinations of 0, 0, and 0. So which indicates A bar, B bar, and C bar. So we write the term as A bar dot B bar dot C bar. Yeah, people, is that clear? Right, brilliant. Okay. Then likewise, we are going to consider the other places of the output. So we got 0 in these 2 places. We are not considering zeros for SOP. We only consider ones in the output. So here we have a 1. So this one has what? 0, 1, 1. So that means you are going to have this 0 indicates A bar, this 1 indicates B, this one indicates C. So that is why A bar dot B dot C is being derived on this place. So in the very same way, this 0 is not considering, and this one is going to consider. So it has a combination 1, 0, 1. So we write that particular term as A, B bar, C, right? So that will give you A dot B bar dot C. And the very last one, this 0 is disregarded, and this one has 1, 1, and 1. So that simply indicates A dot B dot C. So it says like A dot B dot C. So we have 4 SOP terms against the ones of the output column. Now it's a piece of cake. What you are going to do is you just write those 4 terms connecting from a plus, which will give you an SOP, sum of product. Is that clear?
සර් කොහොමද ඔක හොයාගන්නේ මේ කොයි එකට දෙන්න ඕනි කියලා කියන අවුට්පුට් එකටද අනිත් එකටද කියලා කොහොමද හොයාගන්නේ අපි හරියට?
ඒ කියන්නේ output එකටද අනිත් එකටද කියලා කියන්නේ?
අවුට්පුට් කියන කොලම් එකක් තියෙන්නේ. ඒකේ අවුට්පුට් දෙකක් තියෙනවා සර් කොලම්.
ඔයා කියන්නේ මේ කොලම් එකයි නිර්මාණ මේ කොලම් එකයි.
ඔව් කොහොමද හොයාගන්නේ ඒක?
නෑ මේ කොලම් එක එන විදිය තාම නිර්මාණ මම කිව්වේ නෑ. අපිට truth table එකකට සාමාන්‍යයෙන් එන්නේ නිර්මාණ මේ columns 4 විතරයි. මම මෙතන දීලා තියෙන්නේ මේ output එකෙත් complement එක අරගෙන complement එකටත් SOP එකක් ලියන්න පුළුවන් කියලා පොඩි අමතර දෙයක් පෙන්නලා තියෙනවා.
එතකොට සර් අපි අවුට්පුට් එකට 0 දාලා තියන්නේ.
ඒක මේ මෙතන මේවා 0 වෙන්නේ කියලාද නිර්මාණ අහන්නේ?
ඔව්.
මේවා 0 වෙන්නේ නිර්මාණ අපිට දීලා තියෙන සිනාරියෝ එකේ හැටියට. දැන් නිර්මාණයට මතක ඇතිනේ අපි past paper questions කරනකොට එක එක සිදුවීම් දීලා තියෙන්නේ. ඒකේ සිදුවීමට අනුව තමයි මේ කම්බිනේෂන් එකට 1 එනවද බිඳුව එනවද කියලා තීරණය වෙන්නේ. මෙතන මම මේ අරගෙන තියෙන්නේ උදාහරණයක් විතරයි. මේක මේ එන්න පුළුවන් මොකක් හරි එක જાතියක pattern එකක්. That's all. හරි? Right. Okay, people, I think it's clear with you. Right? ළමයි පොඩ්ඩක් confirm කරන්න clear නේද කියලා කතා කරපු දේවල් ටික? Right. Okay. So this next column, this particular one, it is just an extra thing that I am telling you, right? Then again, හිතියට පාඩු නැහැ. මොකද එහෙම තැනකටත් කියන්නේ A level වල එහෙම තැනක් දක්වාත් ඔයගලන්ව එවන්න පුළුවන්. Right? Very nice. Right? So this indicates F bar. That means the complement of F. F ගේ අනිත් පැත්ත. එතකොට මේ F bar කියන column එක, how we are going to generate it? By looking at the F column. So if this is 1, this is 0. If this is 0, this is 1. If this is 0, this is 1. If this is 1, this is 0. If this is 0, this is 1. If this is 1, this is 0. If this is 0, this is 1. If this is 1, this is 0. Right? So when we are having the F column or the output column, it is very easy to generate the complement of the output, which is the F bar. Right? And when we are writing the SOP, we follow the same rule, right? But this time we are going to write a SOP for F bar, not for F, right? So on the F bar column, that means the very last column, we got 4 ones again in these places. So we do the same thing. This one contains the combination 0, 0, 1. So that means A bar, B bar, and C. So you can see A bar dot B bar dot C is there. And we consider the next one, which has 0, 1, 0. So that means A bar, B, C bar is there. So we write it like A bar dot B dot C bar. And this 0 is not considered, and this 1 will be considered. So it has 1, 0, 0, right? So that means A, B bar, C bar. So we can say A dot B bar dot C bar. And this 0 is not considering, but this 1 will be considered. So it has 1, 1, 0. So that means A dot B dot C bar, right? So now we know the all 4 terms regarding the F bar. So we can write an SOP for the F bar. So here we wrote that A bar B bar dot C plus A bar B dot C bar plus A dot B bar dot C bar plus A B C bar. Got it, people? Right, brilliant. Okay, so we'll do some exercise, right? And I want you to, yeah, let's discuss about the POS as well. Then we'll go for the exercises, right? Okay, now next one is about how to derive a POS from a truth table. So these are something very simple. We know how to derive an SOP now regarding the ones. And when we are deriving a POS, we consider the zeros of the truth table. So earlier we consider the places we got 1 in the output. Now we are going to consider the zeros of the output. To write what? To write a POS, product of sums. And people, be very careful on this place. This is not going to happen as the SOP. Now, in SOP, we considered 0 as a bar, 1 as A. Now, when it comes to here, it goes the other way around. Here, the 0 will indicate A, and 1 will indicate A bar, right? People, I have done a mistake by presenting the things over here, right? මෙන්න මෙතන හදාගන්න එක critical mistake එකක් මගේ අතින් වෙලා තියෙන එක හොඳ නැති mistake එකක්, right? අර කලින් graph එක මම copy කරලා ගන්නකොට මට ඒක adjust කරන්න බැරි වෙන්න ඇති. මෙතන just make this as A, B and C, right? dash එක මකා ගන්න, dash එක tipex කරගන්නවා නම් වඩා හොඳයි. එතට dash එකක් එන්නේ නැහැ. Right? Now in the just a second, whether I just want to see whether I can correct that. No, it will take time. අද එක එක සෙල්ලම් දාන්න බෑ. current එක නැහැනේ. Right. So this will indicate 0 will indicate A, B will indicate I'm sorry, 0 will indicate A and 1 will indicate A bar, right? So that is what you need to remember, right? Just a second, people. Right, I have done the amendment. Okay, so people, please do the amendments in the POS. That means in your 15th page, do it like this, right? So 0 indicates A and 1 indicates A bar. So when it comes to the POS, that is what you need to remember. In SOP, 0 indicates A bar, 1 indicates A. When you are writing a POS, 0 indicates A, 1 indicates A bar. So it goes the other way around, right? So as I told you before, to write the POS, we consider the zeros of the output column. So once I consider this 0, it has a combination of 0, 0, 1. So 0 indicates A and 1 indicates A bar accordingly. So here we got 0, 0, 1. That means A, B, and this indicates C bar at this situation. So since we are writing a POS, POS means product of sums, right? So that means we have to derive the sums first, then those terms can be arranged as a product. So that means from these zeros, we are going to produce the sums. So because of that, we write this as A plus B plus C bar. Okay, people, is that clear? All right, good, very good, very good. Right, so same goes with this 0. The 0 has 0, 1, 0. That means you have a here. This indicates a B bar. This indicates a C. So we have A plus, B bar plus, C. And we disregard this 1 since we are writing a POS. So we consider this 0. The 0 has 1, 0, 0. So that means this 1 indicates A bar, this 0 indicates B, this 0 indicates a C. So you can write A bar plus B plus C. And we disregard this 1 again. We consider this 0. The 0 has 1, 1, and a 0. So we are writing A bar. 1 is indicated by A bar. This one indicates B bar. This 0 indicates a C. So A bar plus B bar plus C. So next one is a 1. So we disregard that. Now you have 4 SOP terms. So all you have to do is write them as an order by connecting by a dot, which will gives you a POS, product of sums. Is that clear, everyone? Right.
So ඒකට අපි output එකද complement එකද කියලා හරියටම හොයාගන්නේ කොහොමද ඒක?
තේරුණා නිර්මාණ. I can
දැන් output එක නැති සාර output එකෙත් complement එක ලියලා තියෙනවානේ.
මේ මෙතන ලියලා තියෙන එකද?
ඔව්. ඒක කොහොමද හොයාගන්නේ කොතෙන්ද ඒක යන්නේ කියලා මේ. ඉතින් output එක නැත්නම් ඒ complement එකද කියලා හොයාගන්නේ කොහොමද අපි?
ඒ කියන්නේ නිර්මාණ අහන්නේ මේ තීරුවද පාවිච්චි කරන්නේ මේ තීරුවද පාවිච්චි කරන්නේ කියලා හොයාගන්න එක. හරි. generally නිර්මාණ ඔයාගෙන් විභාගෙදී මේ දක්වා තියෙන හැම ප්‍රශ්නයකම අහලා තියෙන්නේ මේ output එක normal output එක. ඔයාට ඇහුවොත් output එකේ complement එකට SOP එකක් ලියන්න කියලා ඒ නිසයි මම මේක දීලා තියෙන්නේ. right? ඔයාගේ අහලා තියෙන inputs ටික ලියන්න ඒකට අදාළ output එක අරගන්න output එකේ තියෙන ones consider කරන්න SOP එක ලියනකොට zeros consider කරන්න POS එක ලියනකොට. එච්චරයි. මේ දක්වා කතා බහ එච්චරයි. විභාගෙත් එහෙමයි. විභාගෙත් මේ වෙනකන් අහලා තියෙන ප්‍රශ්නවල ඔයාලා තියෙන inputs and the output. output එකේ complement එකක් ගැන තාම ප්‍රශ්නයක් අහලා නැහැ. එහෙම ඇහුවොත් ඔයාට කරන්න තියෙන දේ මේක. තේරුණාද මම?
හරි සර්.
හරි? Right. Okay, so writing the F bar is easy, we know it, right? So we just convert the 1 of the output into a 0. So 1 become a 0, 0 become a 1, this 0 become a 1, this 1 become a 0, this 0 becomes a 1, and this 1 becomes a 0, and this 0 becomes a 1, and this 1 becomes a 0, right? So it is easy. And again, we are writing the POS for the F bar. Still, the rules are going on the same way as it affects on a POS. So we consider the zeros, and we know in here, 0 indicates A, 1 indicates A bar. So according to the corresponding combination for this 0 is 0, 0, and 0. So that means A, B, C is indicated by these 3 places. So we write it like A plus, B plus, C bar. And we got the next 0 over here, and it has the combination of 0, 1, 1. So we have to write it like this 0 indicates A, this one indicates B bar, this one indicates C bar. So we write it A plus, B bar plus C bar. And the next zero is this. The combination is 1, 0, 1. So that means A bar, B, C bar. So we write it like A bar plus B plus C bar. So the last zero is this, which has 1, 1, and a 1. So we write it like A bar plus B bar plus C bar. So that is how you are going to derive the the POS for the F and for the F bar. Okay, people, is that clear? Everyone? Right, great. Okay, so having this knowledge, we'll do some exercises, right? So we will be clear with this much more, right? All right, now you need to do these questions for me, right? So I'll put the questions over here. So you may draw it on your book and you will derive me the SOPs and POS, right? Okay, so here comes the questions. Derive the SOP and POS expressions for the following truth tables. Right? And here comes the first truth table. You may draw it with me so you can hurry up the work. And you should write a SOP and a POS to this truth table, right? SOP term and the POS term. First write it down. Like after a little while, I'll write the second one, right? Just copy it down, then I'll continue to the bottom.
So අපිට output expression එක විතරයි ලියන්න ඕනේ.
Oh, SOP එකයි POS එකයි දෙකම ලියන්න ඕනේ නිර්මාණ. මේ truth table එක ඇඳ ගන්න. right? නැත්තම් තේරුමක් නැති වෙනවා. So when you are done with the first one, there is a second one for you. If you are done, you can send me the photos, right? Then I'll check whether it is gone according to the plan. Right, Nirmana, I received yours. Let me see. And Lalindi, you have sent me a one too. Yeah, Lalindi, yes. Yes, right, okay. Next part of right bar, start right bar, yes. Yes, that's correct. SOP is correct, Lalindi. And the POS, yes, yes, well done, well done. That's correct. And yeah, this one's SOP. Let me see. A bar, B bar, C, A bar, B, C bar. Okay. Yes, yes, that's correct. That's correct. And the POS terms. Okay. Right, okay. Okay, right, yes, very good, very good. Danindi, well done. Both are correct. Nirmana, let me see yours. Oh, Nirmana, කරගෙන තියෙන පළවෙනි වැරද්ද ඔයා SOP එක තියෙන තැන පුතා once වලට විතරයි term එක ලියන්න ඕනේ. ඔයා zeros වලට term එක ලියලා තියෙනවා. එතන වැරදි පුතේ. once වලට විතරයි ඔයා SOP consider කරන්න ඕනේ. POS consider කරන්න ඕනේ zeros වලට විතරයි. ඒ වගේම POS ලියනකොට ඒක plus එකක් විදිහට එන්න ඕනේ. right? ඔයා dot එකක් විදිහටමයි පෙන්නලා තියෙන්නේ. right? බලන්න මේ ටික හදාගන්න. second එකෙත් ඒ අවුලම තියෙනවා. Sachintani, let me see. Yes, all right. Okay, SOP terms are correct. So SOP expression is correct as well. POS terms, that is correct. And POS expression is correct as well. Very good.
සර් කිව්වේ මේ ටේබල් එකද මේ නැතර එක්ස්ප්‍රෙෂන් එක ලියනකොටද?
නෑ ඔයා expression එක ලියනකොට නිර්මාණ
ලියුවනම් නැහැ ඒක වෙනම. මම SOP POS කියන දෙක විතර කියන්නේ. ඒ දෙක විතරයි හැදුවේ.
ඔව්. එතකොට SOP එක ඔයා ලියලා තියෙනවානේ. දැන් අපි SOP එක ලියන්නේ intuit එකේ තියෙන තැන බලන්න. SOP එක අපි ලියන්නේ එක output column එකේ output එකේ එක තියෙන තැන් වලට විතරනේ. එතකොට ඔයා ඔක්කොම ටිකට ලියලා තියෙනවානේ.
හරි සර්.
තේරුණාද? ඒක වෙනස් කරා ඊට පස්සේ expression එකක් ලියලා එවන්න. Nikini, let me see. Yes, yes, the first one. All right.
බින්දුවකින් තන්න ටික හිස්තන තිබ්බොත් ඇද්ද ඒකේ?
ඔව් ඇති. හිස්තනක් මොකුත් ලියන්නේ නැහැ. Right, Nikini. Yes, SOP. SOP is correct. Yes, very good. POS. Yes, yes. POS also correct for the first one. And in the second one, SOP. Let me see SOP. Eba, biba, C, eba, B, C, yes, eba, C, yes. A, biba, C. Yes, yes. SOP is correct. Let me see the POS. BC and eba, BC, eba, biba, C. Yes, perfect, perfect. Very good, Dua. Right. Okay.
සර් POS එකේ output එක බිඳුව වුණොත් නේද ලියන්නේ?
ඔව් බිඳුව වලට තමයි POS output එක ලියන්නේ. Right, so පළවෙනි එක කරන්නම් බලන්න. So I'm doing the first one. So here I'm writing the SOP terms. Then මේ SOP terms වලට තව නමක් කියනවා මේගොල්ලෝ. ඒකත් ඔයගොල්ලෝ මෙතනදී learn කරන්න මේවට කියනවා min terms කියලා. min terms. min terms කියලා කියන්නේ SOP terms වලට. min terms. Right? So we are writing the min terms for once only. Right? So how we are going to write that? Here we got 0 and 0. So we are going to write x bar dot y bar. And for 1 and 0, we are going to write it like x dot y bar. Right? So writing the SOP is easy. Right? How we are going to write the SOP? Let me take this to a little bit further down. Okay, so I'm going to write the SOP. It's going to be x bar dot y bar plus x dot y bar. If you want, you can use the brackets. It doesn't matter if you do not use the brackets. And if you are going to write the POS, now POS has this term called max terms, right? So that is for the POS terms. So max terms considers zeros. So this 0, it has 0 and 1. So we can write how? 0 indicates x, 1 indicates y bar. So x plus y bar. And this, you got 1 and 1. So that means x bar plus y bar. Right? So the final answer is going to be the POS x plus y bar dot x bar plus y bar. Right? Okay, most of you have done it. Nirmana වැරදිච්ච තැන තේරුණාද?
හරි සර් හදලා තියෙන්නේ.
Right. I'm moving to the second one. Right? So the second one, this contains, and I'll make it a little bit bigger so I can write it easily and you can see that as well. Right? So the SOP terms. Oh, hold on. So I call these min terms. For the SOP terms. Right, so we consider ones. So this, and this. So what are they? So 0, 0, 1. That means A bar dot B bar dot C. Right? And the next one is 0, 1, 0. That means A bar dot B dot C bar. Next one is 0, 1, 1. That means A bar dot B dot C. Last one is 1, 0, 1. That means A dot B bar dot C. Right? So it is easy to write the SOP. It's going to be A bar dot B bar dot C plus A bar dot B dot C bar plus A bar dot B dot C plus A dot B bar dot C. Right? Simple as that. If we are writing the min terms or the POS terms, it considers the zeros. Right? So let me have the min terms. I'm sorry, not the min terms. These are called the max terms or the POS terms. Right? POS terms considers the zeros. These 4 zeros. Right? Okay, so these 4 zeros, now we consider the zeros. So we know when we are writing the POS terms, 0 is considered as the natural state, that means A. 1 is considered as the A bar, right? So here for this 0, we got 0, 0, 0. Over here, 0, 0, and a 0. So we write it like A plus B plus C. And for this 0, we got 1, 0, 0. So we are writing it like A bar plus B plus C, because 1 indicates the complemented state. And this 0, it has 1, 1, 0. That means A bar plus B bar plus C. And the other 3 contains 1, 1, 1. So it gives A bar plus B bar plus C bar. Right? So writing the POS term, or the POS expression is easy. So here we go, A plus B plus C dot A bar plus B plus C dot A bar plus B bar plus C dot A bar plus B bar plus C bar. Simple as that. All right, people, please check whether your answers are correct. And if you got any questions, it's the time to ask, right? If you are not getting this still, you can ask me to redo it, right? So I will help. I'll give a minute for you to settle down with this. Sachin Tani, yes, Dua. Let me see the answer. Yes, yes, yes. Okay, you're right, all right. Yeah, SOP is correct, Dua. So the same thing, yes. Yes. Very good, Dua. Very good. Great. So people, any questions? All right. So now I want you to show you something very special regarding this SOP and POS, right? Now, first question that I'm asking about this SOP and POS. Are these expression, like, to which category this expression belongs to? Is it a standard one or a non-standard one? Yes, everyone? Yeah, that is a standard one. Yes, very good, Bashida. Right? So remember, whatever the expression that you are going to derive from a truth table is always going to be a standard expression, right? There won't be any non-standard expressions which are going to derived by the truth tables, right? Now, if you look into the next one, so it is also a standard one, right? It's very easy, very standard one, right? Each and every term contains all 3 variables, right? So we can set it as a standard one. So remember that is a very important fact. If you are deriving something from a truth table, it's going to be always a standard expression, right? And then now I want you to simplify this SOP and POS. Do it on a piece of paper, right? පොතේම කරන්න ඕනේ නැහැ. rough work එකක් විදිහට කරත් ප්‍රශ්නයක් නැහැ. Just simplify this SOP and POS and tell me the answer. Take a 2-3 minutes. After that, we are going to start the operating system lesson, right? So
මේක සිම්ප්ලිෆයි කරන්න කිය ස්ටෑන්ඩයිස් කරන්නේ සිම්ප්ලිෆයි කරන්න
මේ ස්ටෑන්ඩර්ඩයිස් නේ මේක. මේ දෙකම ස්ටෑන්ඩර්ඩයිස්. so ඔයා normal විදිහට simplify කරගෙන යන්න. ඒක ගැටලුවක් නැහැ. right, boolean laws ටික පාවිච්චි කරලා simplify කරන්න.
ඒ කියන්නේ මේ දෙක එකක් විදිහට ගන්න කියන්නේ එක්ස්ප්‍රෙෂන්ස් දෙක
නෑ දෙක එකක් විදිහට ගන්න කියලා නෙමෙයි නිර්මාණ කියන්නේ. SOP එක simplify කරලා උත්තරේ බලන්න. POS එක simplify කරලා උත්තරේ බලන්න. I'll give you 3 minutes to do this. Maximum 4. 12:36. By 12:40, I'm going to discuss. Okay. Right, Pashita. Oh, මේක මොකකට ආපු උත්තරේද? All right, okay. What's the answer for the POS? Yes, others, how about the situation? Time is up. Do you need more time or shall I discuss? People? Okay, Nikini. මට හිතෙන්නේ වරහන් තියෙන නිසා පටලගෙන ඇති කියලා. Okay, let me discuss. Right, okay. So now
SOP එකට එන්නේ x bar plus y bar කියලා එකක්ද?
SOP එකටද? නෑ. x bar plus y bar කියන එක නෙවෙයි. Okay, hear me out. Right? So look at this. Now, regarding the SOP, you got a multiplication over here, right? And another multiplication over here. Right? So what can we do? Y bar is common in these two places. So take y bar out. So I'm taking y bar out. Yes, Bashi, the distributive law. So you are left with x bar plus x. And what is x bar plus x? This equals to 1. So this means you are going to have y bar dot 1. That means y bar. Simple as that. Nikini? Did you got this, Dua? Did you got that? Right. Others, how about it? Is that clear? It's a simple thing. ඔබල මෙතන මේ පටල ගත්තොත් පටලව ගන්නේ මේ වරහන් දාලා තියෙනවනේ. එතකොට ඔයගොල්ලෝ කල්පනා කරනවා අයියෝ මොකද කරන්නේ කියලා. වරහන් නොතිබ්බනම් ඔයගොල්ලෝ එක සැරේ කරනවා. So like when a multiplication inside the brackets, there is no meaning for bracket. Having the brackets is not doing anything different. Like it's not doing anything special in here. Right, so we can just forget about the brackets and just simplify the things. Oh, Bashita, api y bar එක එළියට ගන්න, we use the distributive law. X bar plus x, that is the inverse law. So we use 2 thing, and y bar dot 1 equals to y bar, that is the identity law, one of the identity laws. Right?
එතකොට ඊළඟ කියන්නේ y කියලානේ අතන බිඳුවක් වුණා.
කොතනද මේ
POS එකකින් සෙමේ. දැන් උතනත් y bar common නේ.
මෙතන y bar common කියලා ගන්න බෑ. අන්න නිර්මාණ බොහොම මේ critical වැරද්දක්, හැමෝම කරන වැරද්දක් ඔයා කරන්නේ. දැන් plus එකෙන් බැඳිලා තියෙනකොට we can't take y bar out. අපිට මේ dot එකෙන් බැඳිලා තියෙනකොට තමයි we can take y bar out as a common term. Not it is when with not when it is with pluses.
distributive දාන්න පුළුවන් නේද?
එතකොට ඒකට distributive දාන්න වෙනවා. Right? So let's apply the distributive to this one. So how it's going to be? X dot x bar. So I'm multiplying these two from x plus x dot y bar plus y bar dot x bar, that is because of these two, and plus y bar dot y bar. Right? Then what happens? X dot x bar, we know it is 0, plus x dot y bar plus y bar dot x bar plus y bar, because x dot x is x. So y bar dot y bar is y bar. So now what happens? We can disregard the 0 we got y bar in every other term. So we take y bar out. So what will be there inside the brackets? X will be staying alone. That is this x. Then plus x bar is staying alone. That is this x bar, because we have taken y. Since we are taking y out, it will give us a 1. Methaniන් y bar එළියට ගන්න නිසා that gives us a 1. So now, what's the value of these? 1 plus something. So 1 plus something will give you a 1. So this is equals to y bar dot 1. So again, what you are going to receive? It is y bar. Right? So you are going to receive y bar again. Right? So you can see what the simplified answer of the SOP and the POS gives you the same value, right? So that means the SOP and the POS for a specific truth table, right? Or like the SOP and the POS of the same truth table is going to give you the same value, right? Ekama agaya. Right? Expressions can be different. Anyway, expressions are different because one is SOP and another one is a POS. But the final value it represents, it is going to be the same thing. Right? So this is a very important point for you to understand. SOP and a POS of the same truth table indicates the same value. Right? People, did you get this? Everyone, please give me a confirmation. Did you get this? Right, okay. Right, great. All right. Okay, so I'm going to stop the gates lesson from this point, and I'm moving to the operating system. I think you all received the tute, right? So like you collect the tute from me, and we got a new student in the room. Gayasha duwa himin sare tute එක ඇවිල්ලා collect කරගන්න දුව, right? I'll send you the location. And yeah, we'll move to the operating system, and let's discuss. For that, we got 30 to 40 minutes to discuss it, right? So I'm going to continue the rest of the things of the gates by next week, right? All right, so let's move to that. Let me take the note. And can I know who has not collect the operating system note yet? Other than the Gayasha, right? Gayasha, right? Yeah. Oh, it seems everyone has taken that, right? Okay, that's great. And I'm going to open a presentation which I have made for Guru Gedara, but it is in Sinhala, people, so I may use it accordingly, right? Details keep some videos are there, so like you can just go through and see what it is, right? Okay, let it be. Right, let's discuss about this now. Now remember, now the operating system is a theory lesson, right? And at the end of the operating system, there are some calculation part regarding the paging and all these things, right? So it like more into a theory part, right? So we are just going to know why the operating system, why a system software called operating system is there, right? So as you and me all know, we are like having this conversation using the Zoom, which is an application software, right? And we can't have Zoom in our computer or on our device without an operating system. So if you take my computer, it's the operating system is Windows. So without Windows, I don't have the ability to install Zoom into this, right? So operating system has different kinds of aspects. And in the definition, it describes three major aspects of it, right? So the first one, like if I read you the definition, it says an operating system is a system software that provides a virtual machine, right? So within bracket, I said hide hardware details, provide an interface to application and the end user, and manages computing resources. That is the second fact, right? Keep tracks of resources, usage grant and revoke permissions, and execute application software. So there are three things, right? And that is why I have put this picture at your right hand side. You can understand, or like you can remember the definition from these things. So user is there, monitor is there. So operating system is the one who providing you the interface or the virtual machine. I'll tell you what is a virtual machine, right? And the other factor is like maintaining the applications, or like allowing the application software to run on it. And again, the other aspect is to manage the resources. So when it comes to the resources, majorly it's going to be input devices, output devices, memory devices, right? Those kind of things, right? So why there is an operating system? To manage those kind of things. Now, what is a virtual machine? What are they like terming as a virtual machine? Now, virtual machine means, now think about a bicycle. It is a machine as well, right? So like if we want to ride the bicycle, we have to get onto it and we have to pedal by ourselves, right? I'm talking about a foot bicycle, right? So once we pedal it, we can move it from one place to another, right? So we are physically interacting with that machine, which is the bicycle, and we get used, like we using it for our particular things, right? So the same way, the computer is also a machine, right? So if you think about the computer, right? So if we think about a desktop, we can imagine things, right? So like if you think about the desktop, we know that inside the system unit, there is a motherboard, there is a processor, there is a hard disk, and yeah, there are CD-ROMs, a monitor, a mouse, keyboard, and all these things. And like if you think about those are machines, right? But we are interacting with those components. How we are going to interact with the hard disk? We are not just looked into the hard disk, right? The things inside the hard disk is shown on the monitor. So we are not interacting with the hard disk directly. Instead of that, we just see the content of the hard disk on the monitor. And who's helping to show us the things on the monitor? It is the operating system. So that is what you call the virtual machine, right? Right. So virtual machine without the operating system, like OS right? If the OS is absent in our computer, we don't have a way to interact with this. Right, then in the next topic, you will see how the very first computer, is being interacted. ළමයි මට විනාඩියක් දෙන්න, I have to answer this call. Right, sorry for that. And yeah, so that is why we call this operating system is providing us a virtual machine, right? So operating system is not allowing us to interact with the hardware directly. Instead of that, it is providing us an interface to interact with those hardware. So he's working as an intermediary, right? Now, if you just open your file explorer, right? So when you open the file explorer, you can see all the details, right? You can see the folder structure, you can see how the hard disk is working, right? So you know, like what are the things inside my hard disk, how many partition do I have, right? Where my old details are being categorized and being arranged, right? So we can access the hard disk like this, right? And if you want to see the performance of the other components, we can visit to the task manager, right? And if you go for the more details, if we goes to the performance, it will show you like how the CPU is working, how the memory is working, what are the details of that. So we are interacting with the hardware, which is the memory, the RAM, which is the CPU, the central processing unit, which is the disk, the hard disk, right? And this Ethernet cables, which is the network related one, graphical processing unit. So we are actually interacting with the with the hardwares, but without interacting directly. So this is why the operating system is called, or like operating system is providing a virtual machine to the user. So he can understand the user and interact with it, right? So it is what you call providing a virtual machine. And the next one is about managing computer resources. And you can see now, this is another good example to show that the operating system is managing the resources. So it is keep the tracks of the things, right? Of the CPU, of the memory, of the hard disk, of the graphical processor unit, right? So those kind of things. Then the operating system is the one who determines what are the processors that need to be carried out now? These are the processors inside my computer, right? So all these processors are being handled by the operating system, right? So these are different kinds of programs which is run in my computer. So like it is happening background now, right? So like not all the processors are being interacted with the user. There are some system processors, there are user processors. Now, if you take the fewer details, right now, this shows you what are the programs or the processor or the process which is being interacted with the user. User එක්ක වැඩ කරන ක්‍රියාවලිය ටික මොනවාද කියලා මෙතනින් ඔයගලන්ට පෙන්නනවා, right? But when it goes to the more details, you can see both the user interacting programs as well as the operating system other process as well, right? Oh, Bashito, SSD එකක් තමයි connect කරලා තියෙන්නේ Bashito. Right. So, and the last thing is executes the application software. As I told you, without the operating system, yeah, we won't be able to have the ability to have an application software run on our system, right? So we basically say operating system is the platform of the for the application software. So if the platform is there, then only the other programs come and do their task, right? Okay, people, is that clear? The aspect of the operating system and the and why it is there, right? All right. Okay. All right. So I'm moving forward. So next is about the evolution of the operating system. Now, we are going to talk about how this operating system is made, like what's happened, like what is the starting point, right? So at the very first era, we consider that era as the no OS era. That means you didn't have anything, right? So that is why I'm using this presentation, right? Now this is a picture of that era, and you can see this, all the people are inside the computer, right? So this is the very first days of the computer, right? And it does not have any interface. It has these switches, wires, vacuum tubes, and all these things. So they will input the things using a punch cards, you know, like we discussed those things in the history, and just having the output using some in the very first days, it was the punch card which they used to have the outputs as well. Later they had these printers, the primary printers kind of things, right? So it is just a machine. දැන් අර අපි bus conductors ලගාව තියෙන ticket machine එක තියෙන්නේ. So something similar to that. You just input things and it will just print you out something. But we can't interact it further than that, right? So like here, we call this the machines which has no operating system is there to do the serial processing, right? So serial processing means like process one after the other. මුලින්ම එකක් දෙනවා, ඒක process කරලා ඉවරුණායින් පස්සේ තමයි ඊළඟ එක process කරන්න යන්නේ, right? And it is also a single user system, right? Even though we could see a lot of people are interacting with this. So it's just like logically, it is just one user doing one particular task, right? And this is the important one. The programmers or the users directly interact with the hardware, right? So it is like we are just interacting with the hard disk, we are interacting with the RAMs, we are interacting with the processors and all these things, right? So there were no operating system kind of a thing to act as an intermediate, right? So the programs were directly given to the operating system, directly given to the computer and or the processor literally. So processor will execute it at once, right? So that is like pretty excited. Pretty excited means like pretty straightforward, right? භාෂිත අපිට first generation computers ඔක්කොම non OS කියලා කතා කරන්න බෑ. first generation එකේම කාලයක් යනකොට OS එකක් එනවා, right? simple batch processing system එකක් එනවා. පොඩි කාලයක්. ඒ කියන්නේ අපිට පුතා we can mix the evolution of the computer generations ටික OS generations එක්ක mix කරගන්න බෑ පුතා. ඒ දෙකක් විදිහට යනවා. right? මුල් කාලෙදී අපිට තිබුණ දේවල් ටිකක් later we had the chance to have an operating system, right? So the picture that I showed to you is the picture of a punch card, right? So it basically gives the things, so like it basically input the things using a punch card. So this is a structure of a punch card. As you can see, like zero, the holes and the non-holes part are there. So holes තියෙන තැන් ඒගොල්ලෝ zeros කියලා indicate කරගත්තේ. Holes නැති තැන් they indicate as ones, right? And there were special machines to feed these things. I'll show you a short video regarding this, right? And this particular thing, so the machine was running with this a control panel like this, right? So it is always like this, switches and bulbs and indicators here and there. So we are not getting anything on a screen, right? So we should have, the operator should have the idea which switches to be on, which switches to be off, and what are these indicators are mentioning, and likewise, right? So it was pretty complex, right? අපිට දැන් මේ දවස්වල දුන්නොත් එකක් නේද? We say no, we will do our work. We don't want a computer to be interact with us, right? We won't be going for those kind of things, right? And yeah, this is the thing that I told you, like which indicates the serial processing. So like this particular program one at my right hand side, it is considered as done, and it has been executed. So the second program is executing inside, and the third and fourth programs have to wait until the second program is done, right? And as the features, if I say, so the manual program scheduling should happen. So this loading part, then අපේ computer එක ගත්තොත් we are not doing any manual programming thing. We just run the program that we want. We just double click on it. It will just run, and operating system will do all the things on behalf of us. Here it is not like that, right? So someone should be there to feed the things one by one and see whether it is been processing, and take the output and feed the next, right? So taking a machine එකට දෙන්න ඕන, right? And it was uni-programming, so one program at a time, right? So multi-programs is not possible. Now, if you think about my computer over here, right? So I'm running several different programs now, right? I got the task manager, it is a utility program, and the PowerPoint, and the PDF, the Acrobat Reader, Zoom, right? And the File Explorer is there. So it is a multi-programming one. But in the no OS era, it is not possible. One program at a time, right? And this is the major disadvantage in this era. Processors at idle when loading the programs and doing input outputs, right? So like nowadays, our processor is actually almost, it is not staying idle, right? ඒක හැම වෙලාවෙම බැලුවොත් එයා වැඩක් කරන ගමන් ඉන්නේ, right? And you know now, if you think about a processor nowadays, it is working like it is executing instructions like 1 billion instructions per second, more than 1 billion instructions, right? So staying, like being idling will make a very big overhead, or like make a very big time gap regarding the processor, right? But processor එකට comparatively ගත්තොත් it's a very big time, because if he stays idling for a 1 second, it's a time of executing billion instructions. So it's a very big time, right? අපිට නිකම් පොතක නේද? වාක්‍ය බිලියනයක් කියවනවා කියලා හිතුවා. නැත්නම් අකුරු බිලියනයක් කියවනවා කියලා හිතුවා. Still it's a very big thing, no? So that is how the CPU sees it, right? So in these days, there were no option or there were no solution for this. Until you load your program, CPU have to stay until it is being loaded. And when something is being output using a particular machine, again, CPU have to stay idle without doing anything because it is because of the unit programming. එකක් කරලා ඉවරුනාම තමයි අනිත් එක්කෙනාට chance එක දෙන්නේ. Right? Yeah, so this is a short video about the ENIAC, right? Which is a first generation computer. And you may see how it happens. Podi clips වගේක් තියෙන්නේ. And I'll share the sound with you. Otherwise, you won't be able to hear this. Oh, hold on. I think I have muted. Hold on, people. Oh, for some reason it is stopped. People, just a second.
ENIAC was one.
Yeah, hold on. All right, now you can enjoy this.
ENIAC was 1,000 times faster than any other calculating machine ever built. It could do the work of 20,000 people working by hand. What a desk calculator could do in 20 hours, ENIAC could do in 30 seconds. It could discriminate the sign of a number and compare numbers for equality. It could add, subtract, multiply, divide, and extract square roots. In 1 second, it could add a 5-digit number 5,000 times.
So these are the punch card which is being loaded, right?
ENIAC required 3 times as much electricity as the largest broadcasting station. This wonderful machine, devised by Eckert and Mauchly and their colleagues, had most of the components found in computers to this day. ENIAC's electronic gate, buffer, and flip-flop concepts are standard circuitry today. There is a great similarity between ENIAC and present computers.
So those are the only output kind of things that they were having from the ENIAC, right? The way the bulbs are being glowing, so they just have the idea how it happens. And from the punch cards, they can have more idea about how the output is being generated.
The thousands of tiny neon lights were arranged like an abacus to light up by 5,000 electronic pulses per second.
Right, and yeah.
ENIAC was one.
So that is the no OS era, right? So the next generation is where you were having an operating system, like the very first operating system kind of things, right? So that is called a simple batch system, right? A primary operating system kind of thing, right? So this IBM 704 computer system had this simple batch system, and it was majorly designed, that particular operating system was majorly designed to maximize the processor utilization. You can remember the disadvantage I told you in the no OS era. It was like the processor is like staying idling, like or doing idling when we are doing the input output thing. Still, in this era, it has the same problem, but they have introduced some other techniques to have the or to maximize the processor utilization. I'll tell you how it happens. And they were using this special machine to record the several number of programs in a one particular disk, or like one particular magnetic tape. So it can be directly given to the computer system straight away. Like previously, you can remember I told you it's just a uni-programming kind of a thing, right? It was like one program should be input, it will be processed, and it will be output. Then the next program should be input, it will be processed, and it will be output, right? So here in this era, in the simple batch system, they had this machine to create a batch of programs using a special kind of machine. And then they are going to put it inside the operating system, like all at once, right? Magnetic tape eකට programs ටික දාලා තියෙන නිසා that whole batch can be input to the computer system straight away, right? So with the help of the operating system will help that batch to be executed one after the other inside the process. එතකොට මේගොල්ලෝ reduce කරගත්ත time එක උනේ that loading time. කලින් programs පහක් තිබ්බනම්, like if we assume like it takes 1 minute to load one particular program, so previously we need 5 minutes to load 5 particular programs, right? But now, since we can ready that inside a magnetic tape, having all 5 programs inside one particular magnetic tape, so we can load it, all 5 programs, within only 1 minute. කලින් මිනිත්තු 5ක් ගියා, දැන් 1 මිනිත්තුවකින් ඔයාලට පුළුවන් loading එක කරන්න. So in that case, they saves the time for the execution, right? So then they use these storage devices, right, to store the output of the particular execution, right? So they make their programs, or they load their programs into a particular magnetic tape and input it at once, and later they are recording the output into these magnetic tape kind of things to have the final output, right? So later they can use the printers kind of things to print out, if they really want to print the particular output out for their kind of purposes, right? So basically what they have done is they have given the programs as a batch into the computer. So let the operating systems to take programs one by one and let the CPU to run those things, and later they will store the output inside a magnetic tape, and again they can print that out according to their requirement, right? So this is just a simple diagram to show how it happens. So it records inside a magnetic tape, and it will put into the computer, which has a OS now. So OS load the programs and let them execute inside the CPU, no interaction with the users or any other things. Then later it will be printed out as per the requirement, right? So the features of this, right? So I have put you a particular machine which goes on this particular manner, and you can see there a small monitor over there at the top of the right top corner. So it will show some basic details which is given by the operating system. So now no direct access to the hardwares, right? So we are just including the things inside a magnetic tape, and we are inserting that or inputting that into the computer, and computer and the operating system take care of the execution part, right? Still, this is uniprogram. Batch එක විදිහට system batch එක විදිහට programs ටික input වුණාට, still the operating system does not have the ability to execute all of them inside the CPU at once. Nowadays it happens in many different ways, right? And response time was high. Why? The basic reason is you can load all the things into the system at once, and you can output the things into a specific magnetic tape or a magnetic media. So like කලින් එකින් එක දාලා ඉවර වෙලා output එක ගන්නවට වඩා ඉක්මනට batch එක දාලා process කරලා output එක ගන්න පුළුවන්. So response time were increased, right? And still the processor sat idle during inputs and output, because still when the batch is inputting, there is nothing to do for the CPU, right? And still the batch is being output, still there is nothing to do for the CPU. මොකද batch එක insert කරලා ඉවරෙන් පස්සේ තමයි OS එක batch එකේ තියෙන program එක load කරන්නේ CPU එකට. Once the CPU receive the program, then only it can execute. එතකන් බලන් ඉන්න ඕනේ, right? So once the execution is done, then operating system will take it and load it to the particular magnetic tape, and then take the next program and give it to the CPU. Until then, CPU have to stay without doing anything, right? So still that idling part is there, right? And this is going to be resolved with the multi-program batch system. So that is the next era. So first era is no operating system era. The second era is the simple batch processing system. Now multi-program batch systems. So here, the computer scientist has developed the operating system into a place where it can work with the CPU as well as with the RAM. So now the RAM comes to the stage, right? So random access memory, or the main memory, is the one who is keeping the data or keeping the programs inside it. And CPU is the one which is executing the programs. An operating system has the access to both the components. So operating system can see what are the things inside the memory and who is running inside the CPU, right? So when a CPU is trying to sit idle, what the operating system is just taking a particular program from the memory and send it to the CPU. Okay, don't stay idle. Here is another program, you just execute it. So I'll take care of the one who has been finished its execution, right? So that is the benefit which is given to the operating system, having the ability of accessing the memory as well as the CPU, right? So this is the base that we are using even today in our computers. Now it uses many different technologies like multi-programming, multi-threading kind of things, but this was the starting point, right? To have those concepts, right? So to do this, the memory was partitioned into several different sections, and they could store the programs inside it in those partitions, right? Then, like I said, when the operating system needs to run things in the CPU, it will take the things and run it inside the CPU. Now, this picture explains what happens when a particular program is going to wait, or what happens when a CPU is going to sit idle, right? So the program 2 is the one which was running inside the CPU. So program 2 needs something from the input-output devices. So because of that, program 2 will freeze its execution, because without the resource from the outside, it won't be able to execute. So that means program freezing means CPU has nothing to do with it, right? Then what it does, operating system will quickly take that program and put inside this memory, and it will take the program 3 or the chosen program into the CPU. So it quickly swaps, right? So the idling one or the one who is freezing inside the CPU, taking it and put it inside the memory, and taking a new one from the memory and putting it inside the CPU. So you you may get this feeling, okay, when he's swapping this kind of thing, so we should feel it, nene, make a hira wenna puluwan ek kara kara inne kenek natara karanawa tawa ekkenek danawa. So it should feel, yeah, I felt that when I was operating with the computer back in 2000s, right? But today this is happening in a very speed manner, right? Even we can't like think about that operating system is doing this, right? Ek apita sense novena tarang speed ekakin then siddha wenawa, right? අපි ඉස්සරහට යනකොට කතා කරනවා, right? Why these computers are getting stuck, due to what reasons that this is going to happen, and you'll get to know how the things are being happening in those particular operating systems in nowadays, right? So after the simple batch system, they had this another operating system model called the time sharing system. That is the other era which is generating. Right, so this time sharing system, it is another technique that that these operating systems use. So that is why it's built up a new era. So earlier it was that the operating system took the help of the RAM as well as the CPU to manage multiple programs, right? And here operating system use a technique to give a specific time period for the programs which are going to run inside the CPU, right? So for the programs in the RAM will be assigned a particular time and will ask to run inside the CPU for that particular time period. If you are done with that particular time period, then you can exit. If you don't, come to the main memory and stays until I give you another time, right? So that is what we call time sharing, and operating system is using a concept called context switching. We are going to learn about it at the latter part of the lesson to do this particular task, right? And with this, the multi-programming, the ability to do the multi-programming was increased inside the operating system, right? And this was the technology which takes the user's attention away from the slowness of the computer, right? So user won't feel the swapping and the time sharing is happening. So he will do his work, even just for this moment, we are experiencing that thing. In my computer, there are several different programs are running, but I don't feel that. I'm just working with you, like I'm using the Zoom and I'm showing you a presentation. So two different programs simultaneously doing its work, right? Okay, so this is what you call the eras of the operating system, right? So that is the end of the operating system type. So in your note, I have given you the same things, and you just read it through. The same diagrams I have used in here, right? So until the page number 4, we have the operating system eras, right? All right, so I'm not going to step onto the main functions of an operating system. We'll start discussing those by next week, right? So battery is getting low and the time is almost up. So by next week, I'm going to continue the operating system, some part of the operating system, as well as the gates questions, or like the gates related concepts as well, right? So I'll see you on next week for the very last time, for the very same time, people, not the last time, right? So we'll continue from that point onwards. And yeah, any questions, people, before we leave, before we sum up the session? And people, was it clear about the eras? You got the idea, right? And I will upload the videos for the site again if you want to go through it again and again. Fortunately, the computer did not get off due to the power failure. Still, it got some 28%. Right, okay, people. So I'll see you on next week for the very same time, right, at 11:30. So be there. We'll continue the operating system and the gates as usual, right? Okay, thank you very much, people. You can leave. Have a very nice weekend. And I'll see you on next Saturday for the same time. Okay, Lalindi, thank you very much.
සර්
Right,
මේකේ මේ
right.
ක්වෙස්චන්ස් එන්නේ කොහොමද සර්? කියන්නේ මේ දැන් ඔය ටයිප්ස් ටිකෙන් අපිට කියන්නේ ලොකු ප්‍රශ්න අහන්න පුළුවන් නැත්නම් MCQs වලින්
ලොකු
අහන්න
ප්‍රශ්න
පුළුවන්?
නෑ ලොකු ප්‍රශ්න වගේ අහන එකක් නෑ. Thank you very much everyone who is leaving, right? ලොකු ප්‍රශ්න අහන්නේ නෑ නිර්මාණ. ගොඩක් වෙලාවට structured paper එකේ questions අහනවා. ඒ කියන්නේ operating system එකේ questions හැදෙන විදිහක් තියෙනවා. එකක් තමයි 7 state diagram එක. අපි ලබන සතියේ අපිට කතා කරන්න එකක් නෑ. ඒක තව ටිකක් ඉස්සරහට ගියන් තියෙන්නේ. එයත් එක්ක මික්ස් කරලා ප්‍රශ්න අහනවා. context switching පැත්ත මික්ස් කරලා ප්‍රශ්න අහනවා. ඊළඟට memory calculation පැත්ත මික්ස් කරලා ප්‍රශ්න අහනවා. ඔය තුනෙන් තමයි operating system එක focus වෙන්නේ. ඊට අමතරව MCQs වලින් ප්‍රශ්න 4ක් 5ක් විතර වගේ paper එකේ වැටෙනවා. right? ඒක ඔක්කොම අරගත්තම total weight එක සාමාන්‍යයෙන් ලකුණු 7කට 8කට විතර වගේ යන විදිහට spread එකක් තියෙනවා.
හරි සර්. thank you sir.
හරි. මුල් ටික අපි කරගෙන යනකොට okay වෙයි. Right? Okay. All right, people. Right, okay. I'm going to end the session. Right, okay. Thank you.